Okay, good afternoon, everyone. My name is Felician Farkas. I'm an application engineer for PLM Central. I'm a Creo CAD user, and I also used SolidWorks previously. Um, uh, I helping customers with Creo setting inquiries and licensing issues. Today, we're gonna talk about design composite, which is a popular manufacturer production method for industries where durable and lightweight product finish um, needs for excellent solution for better energy consumption. And also we're going to talk about the Manikin tools. Let's start reviewing the webinar agenda. The main focus on today, as I mentioned, composite design. I'm going to talk about generally about it, the main components, and the three main development stage, how the composite design creation build up, and also at the end we're going to talk about the Manikin tools and its new features in Creo 10. So composite design is a product manufacturing method where we're combining components in a layered structure by laying them into a mold which is responsible for the shape of the whole desired form we want to achieve. This approach aims to achieve a specific performance by combining these elements and optimizing manufacturing techniques for the desired application. The main industries are the aerospace, marine, automotive, consumer product, sport goods, and transformation. Why is it a popular manufacturing method? Because we can achieve some with this method we can achieve some things we cannot achieve any other production method. And then you will see that why, because these combine materials and the properties they give to the final product is unique to this manufacturing process. So the two main components of the composite is the composite material and the matrix or binder. The properties is the most important factor of the use. So the unique properties is key. For example, carbon fiber have high stiffness. Glass fiber have tensile strengths. Armid fiber have good energy absorption and flexibility. Ceramic has like high thermal conductivity. All these properties are the main importance of the composite material as they combine together. So these components are embedded in the matrix or the binder and keep those fibers in place. These binders can be polymer matrix or epoxy matrix. It can be applied by rolling, pouring, injecting, or even impregnated into the composite materials and activated by some chemical reaction in more large scale production. They use that. What to consider during the composite design creation? is the material choice, the environment the product will use, what impact is the product exposed to, and how those chosen material will support that. And we see here the material strength, resilience, durability, flexibility, and thermal conductivity. Also lightweight, it's an important aspect of composite design. And also the manufacturing possibilities, size and form of the product is how the material will form into a shape or a drape around that mold. We have to see the number of layers, the thickness of the material, fiber orientation, which influence the ductility, the bendability as they cross each other in different angle. Similarly, like if you can just see the plywoods in construction, as they have different layers and how they laid it give different flexibility to plywoods. Is similarly to any more confusing composite design material. I just want to show you these pictures with the here helicopter teams building a composite part, applying these composite layers by manually. In the last few slides, I was generally talked about composite design. Now let's see what Creo 10 provides in terms of composite design creation. So we're going to have a look at the composite development stage, design, analysis, and manufacturing preparation. Also the composite design tools interface. And I would like to mention the composite tools are already available on Creo 10.1. And also you need some licenses to be able to use it. And we're going to talk about this at the end of the presentation. So here we see the development stage of composite design, the design stage when we create the model, the product. We are going to have a look at the Creo tools, the composite layers, and their properties, and editing these properties. On the analysis and simulation section, we see how the product being validated with a draping simulation, and then the manufacturing preparation bit. We're going to see how we're creating a 2D version of the composites with the parameters, either is a DSX flatten export, or we're talking about the drawing playbook, which is a brilliant tools. Let's see with more details in the next slides. So we find that composite design tools on the engineering tab. Click on composite. You can see on the left-hand side, highlighted on red. You can see a big green arrow on the top. This will shows the highlighted features we're going to talk. So the first stage of designing the geometry, and for that we need to select our layer surface. You can see on the top with the green dot, highlighted with the first green dot. So on that tab, we're selecting our layer surface, which can be solid or quilt. and also the stacking direction, which direction we want to build up the layers, either inside or outside of the layer surface. Then we need to define the rosette reference corner system, the ply orientation and stacking direction. Then on the third and fourth dots, you can see we create the actual plies, the layers. It can be either a ply or a core. Sorry. Yeah, normally the core is a much thicker surface. It's like a building surface. Obviously have bigger drops, which we can have to set the taper on the edge to transition it. So it's not a bulk step. So we have the feature curve loop functionality in Creo 10. So we have more option to select boundaries or edges on the layup surfaces. We can, once we created one layer, we can add multiple layers. As you see on the pictures on the bottom left-hand side, there is multiple layers with different color, indicating different material. We have the option to split the plies up, use the splice features, and we can overlap this. You can see the start and the finish as it overlaps the top layer on red. We control the layers and transition them with the transition plies feature, stack them in steps, so we can making steps as you see on the transition plies feature image. And at the end, when the composite design ready to solidify, we use an EML quilt, which includes all the layers, and we can use them as a solid model for do a two-part mold for the vacuum process, for the vacuuming process, or make some mass property calculations. Still under the design stage, we look at the model section U, or laminate section. With this, we gain better visualization. We can scale up to view the layers more detailed, how they stack, how they transitioned, visualize the drop-off areas, and we can select that one as well. And we can see the different materials with different colors. Okay, on these slides we see the laminate manager. It's a very important composite tools locating next to the model tree. So the laminate manager also great for visualizing the required field, enable to also not just visualize but change the ply definition and give editing options if we want to change anything from those tabs, sequence, material, and orientation. Also, we can look at the mass properties of each individual layer, and we can organize them sequence as well on this laminate managers, and we can add new tabs as well. We use the analysis and simulation to validate the composite design, where we can check if the model find the requested engineering qualities meet with certain standards. We using mainly the draping simulation to identify the draping issues. We have tools here called traffic light indicator system, green, yellow, red signs, which shows where the ply is good to go with the draping consideration and the shear angle we use for those particular material choose and thickness. So you can see some of them on the first ply is no good to go. Is exceeded the shear angle which not support to having that layer. So either we have to change the thickness of the material, or we have to change the angle, and we have to investigate that. So also we have the stock material calculation shown. So we can specify the stock material size, and is automatically align the laminate layer and give us a notification if the material can be applied in one piece, or we have to splice. We have to cut it and have to use more than one piece. And Creo simulation, where we can do analysis, for example, structural analysis. There is a new enhancement in Creo 10 where we want to run an analysis. We can use the ply information and integrate it into the Creo simulate now with no problem. The last development stage is actually the most effective one, the manufacturing preparation stage, where all design work and analysis will pay off. Creo will prepare the flattening process to create a 2D contour of the ply material of the sheet material. We can export the layers to DXF or DWG format, or we can also use the plybook drawing features by using a template and create multiply sheets separating the different ply surface. So imagine 20 different layers suddenly shows up all in one with one button of click, and shows the desired view, table of content, parameters which is set up in the template. So that's definitely reducing manufacturing time, and we can be more productive, because this manufacturing part of the composite design is need a very nicely structured way to carry out the work. So once we have these drawings, the machine is ready to cut the sheet to size. So you can see the flat version of the product, so it's easily can cut out, and once it's cut out, it's also the drawing will have the layout and the stacking order, also the orientation to carry out the physical work. Sorry, go back one step. Yeah. So yeah, and also we can add other tables from the laminate manager as a CSV file. You can see on the third image on the top, any requested table can be shown on here on the drawing, which is again very helpful. Okay, Creo Manikin extension. Now we're going to talk about the Manikin tools. Human interaction is validify the functionality of the product, and that's what the Manikin tools help with, considering ergonomic consideration, size, shape, human factor. Basically, Manikin helps with the modeling and changeable solution, customizable posture and facing. So Manikin tools improve in Creo 10 definitely, have more detailed control option, use multiply Manikin and separate assembly. Previously was not an option. Use manage multiply snapshot and reach envelope per hand is also a great function. Use more control between join segments. Specific angle can be given between joins. But let's see this one on a short demonstration on the next slide. Okay, so we can insert a Manikin from the Manikin library, choosing the desired model, male or female, different size, different region. We can place, change the facing, the posture. It can be sitting or standing posture. We have a working environment here, which we want to see how the model looks in this environment. We can apply different postures by a macro or a micro settings. The macro settings is more like a full body changing option, as you can see. So we can go to close to the posture we want to go. And also we can go to the micro function where we can changing more small details like hands, how the hands hold or the legs facing. So we have we can manipulate the Manikin by using the drag tools. You can see how effectively we can move the arms around with a rest and go too close to the posture we want to achieve. From the same tab, manipulate the Manikin, we can also set the reach. So we can reach some targets. So as a segment, we selecting the hands and selecting that point as a target. So is holding that armor, the mannequin holding that armor. We can also change the facing. The mannequin we can direct where is his vision needs to be focused. With the snapshot tools, it's a very important thing to save the settings the posture settings we set it up, so we can use it later on or for using different mannequin. We can add more snap shots with a new Creo 10, which is again good, and Manikin can use as a separate assembly. Like before, it wasn't an option. Here we see the vision of the mannequin. And now I showed how to change the mannequin and replace it to a female version of it. We selecting from the library and applied, and also using the saved snapshots, we can bring the posture to this mannequin. So you can see it's holding the armor, same position as the previous mannequin. And that was the last page of my webinar. Now I would like to talk about the licensing side of the composite tools. So Creo Design Advanced Professional Package give you an access of optional models of composite legacy. For the new composite design and manufacturing features in Creo 10.1, the one we just see, you need a premium license. Or there is a possibility to build a customized package using the base license and only using the composite manufacturer functionality without the full package, to use to purchasing an advanced or premium package. So for that, I included into the slide that tool license code. So we would like you to engage with PLM Central and to explore customized licensing solution. So any inquiry you have, please contact us, and we will support you alongside with PTC. And this is the end of my presentation. Thank you for listening. See you on the next webinar series. Enjoy the rest of your day, and thank you. Bye.